derivative must be negative, okay? Derivative is negative, price is positive, Q is positive, so the overall thing is going to be negative, okay? Unless you do something about it, which is, this is doing something about it, okay? D epsilon D minus P over Q dq over dp. If you want this to be positive, that negative sign has to go there, okay? Okay? Because remember, dq by dp is negative, it's always negative. So to get a positive elasticity, you have to put a minus sign in front of the whole thing. Okay? Right. Okay, so that is the Ferris split, which says we define elasticity. They're very short, very brief. No, we don't want any essays. Okay? No waffle, all that sort of stuff. Just stick to mathematical symbols and very brief. Okay? Right, the second thing says try to relate, that's the coursework, it says relate the value of elasticity to the increase in revenue or decrease in revenue. Okay? You relate the value of elasticity to increase in revenue or decrease in revenue, and that's how it goes. Now this is the total revenue, P times Q. Okay? Now if I want to gauge the increase or decrease of the total revenue vis-a-vis price, I'll differentiate the total revenue with respect to price. Okay? If I want to actually see what happens to the total revenue as price changes, I'll differentiate the total revenue with respect to price. Okay? So let me do that. So that is the total revenue, which is PQ. Now I'm going to differentiate this with respect to price. Okay? And here I'm going to use the product rule. Differentiating with respect to P, you do the product rule. dP by dP times Q plus P times dQ by dP. That is the product rule. Okay? So this is equal to Q plus P dQ by dP. Okay? Now if I take Q outside a bracket, and there is a bracket here, I'm going to have 1 plus P over Q dQ by dP. Okay? So that is now the derivative of the total revenue with respect to P. Okay? And then I'm going to see what happens when the price is elastic. Okay? Price is elastic means elasticity is greater than 1. Sorry. Before I do this, let me try to adjust this last term here. This is 1. That term here, this term there, this is minus the elasticity. Okay, let's go look at what we wrote about elasticity. That's minus elasticity. Okay, now if the elasticity is greater than 1, okay, then that bracket there, the bracket is going to be less than 1. And of course, Q is always positive. Okay, so this is positive, this is negative there, and therefore this is, the derivative is negative. If the derivative is negative, that means the function is going down. Okay? That means TR is decreasing. When elasticity is greater than 1 and price increases, total revenue goes down. That's what that says. Okay? So therefore, so TR decreases. Okay? So in the case of elastic prices, increase price, total revenue decreases. Okay? And likewise, if you start your argument from inelastic price situation, okay, then that's going to be positive. And that's going to be positive. Going to be positive. And the sentence in the middle, in the last case, as B increases, total revenue increases when the prices are inelastic. Okay. So, and here meaning building on this, as P increases, TR increases. That's the first part of the task. Second part of the task says you are given elasticity as a function and you are required to use that function to work out the demand equation. Okay? Use the elasticity function, work out the demand equation. Okay? Can I clean this stuff here? So elasticity here is given as this function here. Please don't copy from there because there are some mistakes there. Just focus on here. Yeah? P epsilon D is equal to 2 over 2 plus P.
Do you change it to 1 plus P? But then you'll get P equals 0.
No, 2P. Sorry, 2P. If you get that equals to 1, now you don't get, this case it's okay. Because if you put this equal to 1, then P is going to be equal to 2. Because you have 2 here, 4, 4. Okay, now there is a definition. What is this? We've already said this is equal to P over Q, dQ by dP, and this is equal to 2P over 2 plus P, and this is a differential equation. Okay? We know you solve this equation by separating the variables. This is elasticity, that's what is given. It's given there. Okay? I'll try to show you where it's given. It says here, given the supply equation, this is a supply equation, this is elasticity, okay? Find the demand equation, okay? So you go to the definition of elasticity and you come up with this differential equation here. Differential equation for Q and P. You start off by separating the variables. First of all, I get rid of this P. Separate the variables. I have dQ over Q is equal to twice dP over 2 plus P. Okay? I can write this as dQ over Q equal minus 2 dP over 2 plus P. Okay? And then integrate this side and that side. Right? Let's use integration. This is going to give me lnq is equal to minus 2 ln 2 plus p. I can put take a constant as an ln of a constant. That's possible. I can do that. Okay. So therefore, this is equal to minus ln k over 2 plus p squared, like so. Okay, because there's a number 2 in front of ln, I can put it there. And then there's a minus, I can put 1 over. Okay. Alright, so from this Q is normal. Q is K, and I know that Q is equal to 1 over 4 when P is equal to 1. That's given. Okay. Now these values are used to give K a value. Yes.
P is equal to 1 or 2?
2. Thanks. Okay. Now if I put 2 here, I'm going to get 16 here. 16. And if I put 1 over 4 here I've got 1 over 4 there. So K is going to equal to 4. Okay. So if you substitute P equals 2, Q equals 1 over 4, you will end up with K is equal to 4. So this leads to okay. So this is the demand equation. Use the expression for MR to maximize the revenue. Okay. So I'm going to clean this now. MR, marginal revenue, is the change in revenue by the change in quantity. Okay. So the TR by DQ. Okay. That's a derivative. Okay. Derivative defining the marginal revenue. Okay. Now we know that for TR to be maximum, MR maximum, it cannot increase any further. Yeah. So this is true. So then I'm going to work out this expression now, starting from PQ, okay, and differentiate with respect to as before. So MR is going to equal to differentiate this with respect to Q. PR equal P times Q. So this time we differentiate with respect to Q, but it's very similar to differentiating with respect to P, just interchanging the role of Q and P as previously. So you are going to end up with P here plus Q dP by dQ, like so. Okay. So I'm just getting with this. And B outside, I've got 1 plus Q over P dP by dQ. Okay. Now the last expression, this bit here is elasticity upside down. Okay, this bit here is elasticity upside down, so I can write this as P 1 minus 1 over P epsilon naught D. Okay. Now if you put that equal to 0, and we know obviously the price is not equal to 0, so therefore the bracket is equal to 0, which means elasticity is equal to 1. So MR equals 0 implies that elasticity is equal to 1. Okay. Now what is elasticity? This is 2P 2 plus P equals to 1. Okay. That is elasticity as given. This is elasticity there. Okay. So that means the price, if you solve this, you get P equals 2. It's a cross multiply, it's a very simple equation. We put 2 here, that's 4, 2 there, that's 4, and you divide, the answer is 1, okay? I don't know how I got 0 previously. Okay. So, so that at that price, the total revenue is maximum. It can't be more than that. That's the price which actually gives you the maximum total revenue. Okay, that's okay now. Now it says here, the next bit says find the equilibrium price. As we know, when equilibrium price, this is the price when demand is equal to supply. Is that correct? Equilibrium price is when the demand and supply are the same. Okay? So that is the supply equation. This is supply equation there. And we have got the demand equation somewhere a minute ago by solving a differential equation. So equilibrium price is when supply is equal to demand. Okay. Okay. Now supply equation, that is the supply equation, is Q equals V squared plus a half. The demand equation is what we got from the differential equation. Okay. So if you want the equilibrium price, you put them equal to each other. So that's V squared plus a half. This is Q in the supply, the Q bit of the supply equation, and the Q bit in the demand equation is 4 over 2 plus B squared. Okay? So when you get the value, solve this equation, the value of P is the equilibrium price. Okay? So it's equal to 2 plus B squared into B squared plus a half. This is equal to 4. Try to solve this equation there, okay? The nasty looking equation. Okay, there's no way of finding an analytical solution for this, but the coursework says you use the decimal search method to find the solution for this equation. Okay? Use okay, I did look at this equation using the decimal search earlier. Okay. And this is what I got. Okay, I started because it says in your coursework give your answer correct to 5 decimal places or something. Okay. So when I looked at this earlier on, I started. First of all, I looked at this expression here. Look, tell you what I did. If I substitute 0, so you substitute 0 here, okay? You get a positive value, don't you? So if you substitute minus 1, okay, substitute minus 1. Actually, I'll tell you what I did. I looked at this function here. This function here looks like so. If you just draw a function, it just looks like so. This function looks like so. Okay, this is a parabola. Okay, x squared plus a half, yeah? And this is like something divided by x squared, which is coming down from above. And I know they just met somewhere there. Okay, they met somewhere there. But then, what is that? So if I take a value of 1, for example, put it there, I've got a positive value. So I know that value between 0 and 1. This is how I just looked at the graph. So you draw the graph of left hand side, you'll be able to see that the root is between 0 and 1. Okay? Just look at the graph. Now when I looked at the graph and then I started the normal decimal search method here, you've got this expression there. This all that expression here, and table after table after table after table until I got an answer correct to 5 decimal places. I think we did that in the class, and hopefully everybody knows what to do. Okay? So then that is the first part. Second part of the coursework done. That's what it is. Any question? Quickly. We've got a couple of minutes. Any question? Actually, there is some correction in the coursework. I'm going to send it to you by email quickly soon. Yeah. Slight correction. We're going to omit the last question. It's not needed. Any question? Quick. Okay. Now, when it comes to writing, I'm not interested in essays. Okay, so you're not going to get any credit by writing to me an essay in economics. No credit. Okay, just stick strictly to mathematics, but define your terms clearly. Okay. Okay. Right. Okay. Move on to the next part.
I think we should be open already.
Huh?
It's already open.
Huh?
It's open. It's open.
Is it? Oh my God, I can't see.
Obviously,
Okay.
can you make it bigger? Zoom in a bit more. Yeah, that's better.
Can they see now?
Yeah, that's better.
Okay, the first part of the coursework now. Now, this is not quite the function you have in your coursework, but very similar. Okay, so we want to go through this various stages of the coursework in relation to this function here. Okay, the first part is to find where the graph of this function meets the x-axis and the y-axis. Okay, so this graph does it meet the y-axis? Y equal fx does not meet the y-axis because it's not defined. Okay, because it says here definition does not include 0 equals x equals 0. Okay, so the graph is not going to meet the x-axis. So y equal fx will meets x-axis when fx is equal to 0. That is fx there. Fx is a fraction, as you can see, top of the fraction divided by the bottom of the fraction, which means the top of the fraction when ln 1 over 4x squared is equal to 0, when 1 over 4x squared is equal to 1, which implies x is plus or minus a half. These two are the x-coordinates at the point where the graph cuts the x-axis. Therefore, y equal fx cuts the x-axis at a half 0 and minus a half 0. Okay, these are the 2 points where the graph cuts the x-axis. Okay? The second point shows that fx has exactly one stationary point. Okay, and that this point lies between a half and a 1. Okay, so this is the first bit. Second bit. This is going to be the second bit. It says here 1, but it's actually 2. Okay? Okay? So y equal fx has a stationary point. When whose x-coordinate, if the x-coordinate satisfies f dash x equals 0. That's the main thing. So I'm going to get hold of f dash, equate it to 0, and try to study the consequences of doing that. Okay? What can I say about that? Okay. Now I'm not going to go in. I'm not going to write things nicely and neatly about this part because it is quite a job trying to explain what's happening. Okay, so I'm going to focus on the explanation rather than the writing part of this part. So I'm going to move on to where this is done. Now this is y equal fx, and this is how it is, how f dash is obtained. Okay. Clearly, using the quotient rule here, as you can see. Okay. So use the quotient rule correctly, and then continue to simplify. All use steps to simplify your working until you get this point here. Okay, so continue simplifying until you get to this point here, and then what you are going to get is twice, and then in bracket 1 minus e to the 2x plus 2 e to the 2x x ln 4x squared divided by, and then there's a quantity at the bottom here, x bracket that quantity squared. Okay, so just take your time, do your differentiation, take all the time in the world, do the differentiation correctly, simplify correctly. Okay. Ultimately, attention please, ultimately that's what you are going to end up with. You are going to end up with f dash equaling, attention please, 2gx divided by x, and then that bracket is squared. What is gx? This is gx. It's 1 minus e to the 2x plus x e to the 2x ln 4x squared. That is what happens when you do carry out differentiating x correctly. By the time you finish, this is what you get. So now the question I'm trying to answer is how many roots am I going to get for this equation here, f dash x equals 0. Now f dash x equals 0 means putting this equal to 0. Okay? But this is going to equal to 0 if and only if gx is equal to 0. So therefore, the problem comes down to looking at gx and see if it has any roots, and if so, how many roots. Okay? That's the problem comes down to this. Problem comes down to what are the roots of gx. Where is gx? This is gx. Here it is 1 minus e to the 2x plus x e to the 2x ln 4x squared. Okay? Move forward. So the question in the coursework says, show that this equation has got only one root, and that root lies, according to this class here, lies between a half and 1. So I'm going to, from now on, forget about f for the time being and just focus on g. Okay? So this is gx there. Gx is equal to 1 minus, if I write this down correctly, e to the 2x plus x e to the 2x ln 4x squared. I'm going to completely forget about fx for the time being, focus on this. I'm focusing on gx equals 0. Now I'm going to look first of all for positive values of x. I'm going to look at x greater than 0. Okay? All x's that are greater than 0. Now this can be written, all that can be written as that. Okay? All numbers from 0 to plus infinity. Okay? But this can be written as numbers from 0 to a half, and then numbers union the numbers from a half to 1, and then union. Okay, just try to organize my my thoughts. Okay, so this is here. If you look at this, is just the line. This is 0. This is all this line there. This bit here. Now this bit here on the right hand side is 1 to a half, half to 1, and then the rest. So just dividing this bit here into 3 bits. Okay, between 0 and a half, between a half and 1, and then from 1 onward. Okay, and the first one is from 0 onward. the same thing. Okay, just 3 stages. Now, so I'm going to focus first on the first part, this bit here. So for this bit here, okay. Now, if I look at gx, remember x is here, x is there, x is in this bit there. If I look at gx here, this is going to equal to 1 minus e to the 2x plus x e to the 2x ln 4x squared. Now, this bit here is greater than 1. Okay? Because just look at the graph of e to the x. Okay? This is greater than 1. Now, this bit here, okay, when x is equal exactly to a half, ln is equal to 0. Less than a half, that is negative. So this is negative. So this bit is negative, that is negative, and therefore the whole thing is less than 0. Okay? So for if take any x in this area, gx is less than 0. If it is less than 0, it is not going to equal to 0, and therefore there is no root there. Okay? Gx less than 0, and hence no root. So this is out, sorry, no root there. Okay. Now, if I now look at g of a half, okay, this is going to equal to 1 minus e with a half there. 2 times a half is just 1. Now, if I put a half here, in place of x squared, I get 1 over 4. 4 times 1 over 4 is 1, and this is going to equal to 0. Therefore, the whole thing is equal to 0, and this is just g to the half of this, plus 0. Because a log, if I put a half here, I'm going to get 1 over 4. Cancel the 4, you'll have 1 inside the bracket, and log 1 is equal to 0, and therefore the whole thing at the end is equal to 0. Okay? And this is less than 0 because e is greater than 1. Okay? G of 1, okay, this is equal to 1 minus e to the 2 plus 1 e to the 2 plus times ln 4. Now, 4 is greater than e. This is greater than e. And therefore, ln 4 is greater than 1. Because ln e is just 1. 4 is greater than e. This is greater than 1. And therefore, these two, this is greater than this. And therefore, the whole thing is positive. Okay? Okay? This is greater than e. This is greater than 1 means this is greater than e squared. And therefore, these two end up in total with a little positive number plus 1, that's a positive number. Okay? So therefore you can see here the graph is negative and here it is positive. Okay? So from these two, okay, there is at least, there can be more, okay, but there is at least one root. Because the value of the function at a half is negative, at 1 is positive, therefore you know there is at least one root. There could be more, okay, but there is at least one root, okay. Now to finish the whole job is to show that there is exactly one root, okay, and this is done as follows. I'm going to look at now at g dash of x. Okay, g dash of x. And g dash of x, I'm just going to copy it from there. I'm not going to spend time doing calculations because that's going to waste our time. Now g dash of x, as you can see, there it is. This is 2x plus 1 into e to the 2x ln O. So you again used to go to g of x, okay? Where is g of x? It's somewhere. G of x there it is anyway. That's g of x there. If you differentiate this correctly, okay? Differentiate term by term and use the product rule here and so on. That is the answer. Okay? Now if I look at what happens if x is greater than a half, now what happens to this expression here? I'm going to look at this expression there. Now this is going to be positive. 2x, any number which is greater than a half, substitute it into 2x plus 1, end up with a positive number. E to the 2x is positive. Okay? Now a number greater than a half means